All right, so let's start with this slide. What is data science? So we read this chapter for today, right? When we say data science, what are we talking about? What does this encompass? Okay, possibly math. Most of the math is relatively easy math, right?
I think data science analyze all the data that you have and make this data tell a story.
Okay, so I like that. I like that. We're gonna put that in here. Look at data and make it tell a story. Look at data and make it tell a story. Okay, that's good. What does that data look like? What's the challenge with data? What is data? That's kind of on our next little thing here anyways. What is data?
All information that you have, like social media information, business information, healthcare information.
Okay, so
I think information is the gathering of data, no? Data itself is just separated. Data. It's like, I think information is a gathering of data. That's what makes data.
So you're looking at a slide right now. Is this data?
It's a dot, yeah. It is. There's a lot of data there.
There's some data, right?
Yeah.
Okay, now if we paused and I had you come back in 20 minutes and we had the slide gone, could you tell me what the slide still said? You'd remember it, right?
Yeah,
This is from a human being's perspective. Data versus datum, easy, right? We can store that in our head, and that's something we can work with. What about if you read one page in a book? So pick your favorite book. Any book you read one page in that. Is that data?
No, that's information, right?
Well, keep going. So it's data.
That's a gathering of data.
Okay, so but that's more data, right?
Yeah.
Could you read a page in a book and then come back in 15 minutes and tell me what all those words were?
All of them?
All of them.
Probably not. But
Okay. Could you come back in 15 minutes and give me tell me a story about what you read on that page?
Yes.
Probably. Okay. What if you read the entire book? Could you come back and tell me a story about what would it be missing some details?
Yeah, probably.
So the more data you're fishing through, the harder it is for a human being to tell that story. Is that a fair assessment?
Yeah.
All right. So the more data we have, the harder it is for a human to tell this story. Okay. Now, what does data look like? When I say data, does that indicate the format of it?
No.
So when you're reading stuff in a book, or you're looking at this slide right now, let's say, does this slide make sense to you when you read it?
Yeah.
Why? Why does it make sense? This is meaningful to you right now, right? Why? You can read this language. It's organized in a specific way.
Yeah.
Okay, it's organized in a way that you're comfortable with, right? It's like, oh, it's in the English language. So, I read it, I kind of, D-A-T-A right next to each other. That ultimately gets pushed together. The fact that they're in that order means something, all that stuff. So you can start pulling meaning out of this. Now, what if I had this exact same data, but all jumbled up? Would this slide mean something completely different to you? Or if it was in a different language that maybe you didn't speak, right? Huh?
It would mean something, but it wouldn't mean anything to you.
Right, so same data is present. It just has lost its semantics, right? It no longer has meaning because it's not organized in a way that we can process it and tell our story, right? Okay. So when we talk about data, we're really talking about collections of information, whether, don't get caught up on the whole information versus data versus what everything. We have stuff, right? We get a big collection of stuff, but it makes no promises about the organization of that stuff. Now, the more organized the stuff is, maybe the easier it's going to be for us to tell that story. But even with very organized data, if there's a whole lot of it, it's going to be hard for us to tell that story, right? And sometimes saying that, what does it mean when we say something is organized? What does it mean to be organized?
Standard.
Okay. So following a certain format, so maybe follow a standard. So kind of a common standard might be CSV, comma separated values, something like that, or Excel is a standard format. Okay, so it follows a standard, but even at the higher levels, this is more at the, saying it follows a standard like CSV is more at the technology level. But when we say that something is organized, like if I pointed at something and say, is that organized? You say yes or no, but how are you measuring that? Go ahead.
Patterns.
Okay, tell me more.
Seeing patterns within what you're looking at. And if anything
You should have stopped there. Like patterns? Okay, tell me more. Seeing patterns? Tell me even more.
So one
Grouping
of the
things together.
interesting is if we delete all the space in English, we still don't understand it. Possibly we still don't understand.
Can certain things be organized? Can you have two things that are organized, but one of them be organized better?
Yes,
Okay.
of course.
So how do we judge what being better organized means?
When it's meaningful, when something makes sense.
Okay, so it really comes down to whether something. Yeah. So well, it could be. So I mean, what's interesting about some of this stuff is a lot of times it really kind of shows the greatest strengths and the greatest weaknesses of people. When you try to, and I kind of like this idea of telling a story from the data, it does show our greatest strengths and our greatest weaknesses. We are very good at reading between the lines as human beings. We can kind of take things that maybe feel a little dissimilar and draw conclusions about them, as long as we have a relatively small number of inputs to work with. As soon as we kind of get overwhelmed, we break down. We're not able to handle stuff. Now, sometimes, and the example I always like looking at with, so when I said what is data science, this guy's gone by many different names over the years. Years and years and years ago, when I was first exposed to it, was something called data mining, yeah, whatever. So it kind of gets rebranded every decade or so. And now it's kind of at an exciting time for it because now we're at a point where it's kind of hit a crossroads with artificial intelligence and machine learning. And we also have the computational power and specialized tools that allow us to do stuff with it, right? Before this, for a long time, we've probably had the computational power, but we haven't had the interest interest or the needs or even the data. We didn't have the information to process, right? It was something like 90% of all the data that has ever existed has come into existence in the last 10 years or something like that.
Yeah,
Whatever it is, we haven't had the motivation for whatever reason to create specialized tools for working with big data sets, even though we could have written custom software 15, 20 years ago to do this kind of stuff. And in some ways we have. I mean, if you remember last year in the 518 class, for those of you who had it, we did some screen scraping stuff, right? So we had a website that had, what was it? Like,
yes.
yeah, flight schedules, like direct flights from different airports and stuff like that. It was in the data. Was the data in a standard format? So let's
did take it from
It was.
What format was it in?
CSC.
Was it in CSV? Oh, it was. We didn't just screen scrape it right off of HTML, did we? Yeah, so it was in CSV format.
Hold on.
No, I'm catching you up. I'm catching you up. You're not lost yet.
I want that though. I need that actually.
What, for direct flights?
You're grabbing things that was not standardized and transforming CSV or whatever.
Look at his score list from 518.
Oh my god, I need that so much.
Yeah, so what we did is we took, but we didn't use specialized tools. We wrote our own tool, right? So we wrote our own tool, and we split it on commas and pulled out the individual pieces and things like that. So we processed the data ourselves. We're like in the book, they're having us use Python tools like pandas and things like that, which is a set library for doing some of these things. All right, but this idea of data science, data mining, whatever's been around for a long time, and kind of the famous example, I don't know if they still use it in books, but the famous example from textbooks years ago was the idea that in a grocery store, the beer and the diapers are near each other. So the old adage was this: the people who buy beer also tend to buy diapers. And so kind of some of the early things dealt with like a Walmart. Collecting a whole bunch of data because that's a centralized place where a lot of people shop, right? So they were able to create their own internal data sets and then try to mine information, pull meaning out of that data. And one of the interesting things related to that data ultimately came down to the funny. There was lots of interesting things that came out of it. One of the funny things was this idea that, oh, you know what? An interesting, a relatively high percentage of people who come in to buy beer also buy diapers at the same time. Vice versa, there was a reverse correlation. So now it might make sense to put them near each other in the grocery store, right? Or put them very far apart from each other in the grocery store, so you have to do a whole bunch of shopping in between. Make sense? Okay, so there's rationales for, it was just the wind. I saw it kind of crack open. It's fine. It's just going to close again on its own. I'd leave it closed. Blade.
Actually, it is closed.
Yeah.
I just try to make sure it is not someone playing jokes.
Oh, no, I was watching it. It was just kind of slowly creaking.
I can't remember where I heard that from, but it was Target, and they were like the first people to kind of do stuff with that data.
Mm-hmm.
I thought it was in an audiobook. I can't remember which.
Yeah. But I mean, so this stuff has been around for a while, but generalistic data sets are kind of becoming more popular. I mean, we've been working with data for a long time. In fact, in marketing and any sort of business vetting type stuff, we might say data is king. In fact, a lot of places, they, how sometimes you have to check a box that says "Don't share my data," because a lot of places that give you free services, that's like, oh, well, why is this app free? This does such a cool thing, blah, blah, blah. Well, they're selling your data on the other end. It might not be personal data, but maybe that's your email address, or maybe it's just demographic information. So it doesn't have your name, but maybe it has your gender and age. And, and now they're able to track you as a human being who is male or female, who is doing, searching for these types of things. Or doing this type of thing on this site or using this tool, whatever, and they're able to draw correlations based on that age group and what they do, that kind of stuff, and that data is worth something to somebody else. So they might give it to you for free to get as many people signed up as possible to increase their size of their data, and then they go and sell you to other people, maybe anonymously, but they still sell you to other people.
Yeah, that's what Google does with the Google Ads, right?
Mm-hmm. Yeah, they target it towards you based on who you are and who that ad is trying to reach. Okay, so this thing has kind of gone by a lot of different names over time. But when we talk about human beings can handle, we already said smaller data sets, right? But they also need fairly related pieces of information. We're smart in that we can draw some correlations between stuff that might not seem obviously connected. But if it might be pretty quick for us to look at two columns in an Excel spreadsheet and say, those have nothing to do with each other. That make sense? For instance, if we just kind of think about some real life examples. Do you think that speeding has anything to do with the color of shoes people wear? That seems like it wouldn't make sense, right? That doesn't seem to be related. Could it be? Might it be? What if we actually had the data set of all the speeding tickets over the last 5 years in Milwaukee County. And for some creepy reason, we have a picture of each of their shoes. The cop comes up, please step out of the car. Just takes a quick snapshot. It's like, okay, I'm good. So yeah, some crazy complaints, right? I mean, guy let me off with a warning, but why do you need a picture of my shoes? All right, so, but let's say we had that data. It's possible, using some tools, we might actually find that there is a correlation between a human being. I mean, why does a human being buy a certain color shoes? Maybe. There's all sorts of, so think about the rationale, the reasons we make our decisions. Sometimes we can explain it, right? Sometimes we can't. Like, why am I wearing, well, the reason I'm wearing these shoes is because I had to throw my other ones away. I didn't have shoes. But I happen to have another pair of black shoes. Why do I wear black shoes to teach?
Black matches everything.
Okay, or these aren't like super dressy shoes, but there would be dress shoes type thing. They're not tennis shoes or whatever. They're casual business loafer type things. Why do people wear those for work? Are they kind of just generically considered, like for guys, that's kind of like work shoes, and usually do a brown or a black, and that's just kind of the go-to move, something like that. And maybe if you're playing sports, the color doesn't really matter, but it's more of a style of shoe. But some people like a certain color shoe, right? Have you noticed that like basketball shoes come in different colors than like running shoes? Because they've done some maybe demographic testing against who plays basketball versus who runs versus who plays tennis versus whatever. Okay, so is it possible that a human being chooses, because at this point we don't know where these folks were driving, right? They might have been going to work, they might have been going to the gym, they might have been on vacation, we have no idea. But is it possible that under the hood a human being makes a decision about the color of shoes that they are going to wear or going to buy for some sort of consistent reason? Is it possible? And might it be, let's say that people who have gray shoes, I'm kind of maybe picking maybe a less common color, something like that, have a higher incident of speeding. Does that feel like it's maybe a little bit more believable for no good reason than what we just said a minute ago? Like, does shoe color have anything to do with speeding? Well, now, gray shoes. Well, I don't see a whole lot of people wearing gray shoes. That guy seems like he might be a speed demon, right? He could be a guy who speeds. If we had that data, there's possibilities, there's correlation between something that a human being would say that those have nothing to do with each other. But there is logic caught in the middle that actually does have something to do with it. We just don't see it as a human being. And where I kind of make this interesting connection, I'm going to talk about machine learning here for a second. So let me go. When I say machine learning, what does that mean? Anymore, now we just call it ML, right? So what is machine learning? What does that refer to?
Getting a pattern from data.
Well, sure. There's truth to that. What does learning mean? Let's start with when we learn, what are we doing?
Building up a neural connection.
Okay, something magical is happening in our brain, right? So we could say we're building neural connections or whatever, but something's happening in our brain where something we were maybe just introduced to is now something we're more familiar with, then we're even more familiar with, then we're even more familiar with. And then at some point we proclaim ourselves as being competent, okay, or being knowledgeable or whatever, right? Some pattern or something has been captured where now we know something that we didn't know before. Okay, or we can make decisions based on something that we couldn't make decisions on before. So that's what learning is. And we just described humans learning. How do we learn as human beings? What's our process for learning? If we had to come up with an algorithm for, well, let's pick one. Give us a learning style. What's a pattern of learning for human beings? Okay, so doing something multiple times. Repetition tends to be fairly common in most of our learning patterns, right? We can't just do something one time unless it's a very trivial task, right? But, a more complex pattern we're trying to learn, we usually have to repeat that pattern multiple times until we build up a proficiency with it, right? So repetition's involved. Anything else? We don't have to go too deep into this topic. So let's maybe get one more piece. So we have repetition, and what else?
Connecting to exist experience or knowledge.
Okay, so maybe kind of thinking about things in terms of things we already know. Trying to kind of bolt on to something and say, oh, this is kind of like this. If you ever start playing a new video game or something like that, it's like, oh, the controls are sort of like this other game or something like that. All right, so human beings kind of have the starting point of, they say, okay, well, this is how I learn. Now, it might be very difficult, and this kind of goes back to, when we first learn about computer programming, we say that, well, programming is hard because human beings are so good at solving problems that we have trouble articulating how we solve them. So it might be, just like we saw here, it's hard for us to even describe how we learn. If you want to go learn a new task, what do? Let's say you wanted to learn how to knit. Knit.
Oh.
They have knitting in China.
Oh, I see.
Yeah, that's the sword. That's the sword one, right? Yeah. So you want to learn how to knit. What do you do? If you wanted to learn how to knit, what do you do? Ask grandma. Okay. So no, this is connected. So this is kind of like past experiences, right? It's like, oh, well, grandma knits. Let's just go right to the source. I think she was knitting before anybody else was knitting, right? Okay, so you go ask grandma. You watch a YouTube video. First of all, you go onto Amazon. You get my first knitting kit, right? That has like the My Little Pony ninja stick things, and I did. But you go and get your equipment. So if I'm going to learn how to knit, you got to have the stuff you need to knit. Then you're going to go watch a video or talk to grandma, get a demonstration of knitting. Give me the high level, give me the gist of what we're trying to accomplish. Understand the problem, right? Before we can solve a problem, we have to understand the problem. Now we understand it. I want to take these sticks and stuff like that. I want to do that. I want to do the knitting thing. So now you got to get down to the details, right? What is the individual little tiny moves that we're doing to accomplish knitting? So you do one little move and another little move, and you put those moves together, and all of a sudden, haha, you're knitting. Right? So now you know how to knit. Now you got to start, once you start getting better at knitting, now you think, oh, well, what should I knit next? Now it's a matter of what do you make with knitting? Okay, so when a human being wants to go and learn something, we kind of just say, oh, I'm going to go learn this, and we have our kind of our go-to moves, YouTube, grandma, whatever it is, for that starting point. But now, we're kind of lazy, right? If there's things that we don't have to learn how to do, but maybe a computer can do it for us, we kind of like taking advantage of our computers, don't we?
Yeah.
And that's a hobby of ours. Okay, so we have to figure out, well, what is the core component of learning so that we can program a computer to learn? All right, now, the science behind that has more to do with like an artificial intelligence, machine learning specific type class. But the idea here is that there's different kinds of machine learning, just like there's different ways that patterns of learning that human beings go with. But my first experience with machine learning, which to this day still fascinates me, some of you have heard this story before. It's we were trying to write a neural network. So neural network, so this is a fancy way of saying simulation of human brain thingy. So as far as we understand the human brain, it's a simplified model of the human brain so far as we can understand it. It's built on top of this simplified neuron thing called a positron. So unimportant in this thing. All right, so we built this neural network. We say, okay, well that looks brainy enough to us. So now we want to teach that neural network. Human beings, we can do a little bit more than just do multiplication, which is the problem we're going to try to solve here. But we probably don't need our whole brain to do that. So we're going to call this enough brain. So we wrote a little model of a human brain called a neural network, and we said, okay, we're going to teach that how to do multiplication. Okay, but we wanted to learn how to do multiplication. So what did we do? Now let's pretend like this is a person. And this is kind of where it kind of gets interesting. And we'll turn it into a violent story because it'll be funny. So the human being version of this, of how this machine learning worked is, so we're going to have we'll use a fictitious person in front of us, so we won't actually, associate a real name with them. Okay, so this is, what name do we want to use? Yeah, okay, so we'll use Amish. Okay, so we have this, we got this guy named Amish. Do you know the backstory?
Well, because of the religion.
No, it's a real person.
A real person called.
Yeah, it's a backstory in the department, yeah, so years and years and years ago, yeah, well, this is the quick version of it. Years ago, we had a student sitting exactly where Maddie is sitting right now. And his name is Jordan Mather. He works up at Acuity now. And he, very first day of class, in the very first programming class as an undergrad, I was talking about some TV show or something like that. And, I asked him, hey, have you seen that? He said, I don't watch a lot of TV. So I assume, oh, no TV means no electricity, must mean you're Amish. That day forward, everybody knew him as Amish. As a senior, they did not know his name. It was a quiz question as a senior. So it kind of stuck, and they all embraced it. We would come to class, and there was some Family Guy video where, there was all these Amish guys building a barn like instantaneously, and they kept blowing up the barn, and then they would put it back together really quick. All right, so Amish is making a class visit for us. So, so he's sitting here, and we're going to try to teach him how to do multiplication. Okay, but we're going to do it in the way that we did this in my first experience with machine learning. And you tell me if you think this would work with people. All right, so we're going to go up to Amish, and we're going to say, okay, we can call him Jordan. He's an adult now, right? Okay, we'll call him Jordan. So I say, Amish, here's... what's 1 times 1? Now, what would all of us say in here? 1 times 1 is 1. How did you know that?
Memory.
Oh, you already know how to do multiplication, right? Or you just know that one? 2 times 1, do you know that one?
2.
3 times 1, you guys are cheating. You can't do this one. So we're gonna stick with Jordan here, okay? So Jordan's gonna make a guess. He's gonna say, I say 1 times 1, and Jordan's just gonna blurt out some number. 7. Is that the right answer?
Wow.
No. So we're gonna smash him. Okay, we'll punch him in the face. We'll say, wrong answer. Do better next time. Okay. Jordan kind of shakes it off and kind of updates, gets his wits about him, and in his head it's like, okay, well, don't say 7 next time. They say 1 and 1 times 1. Keep going through the list. It's like, okay, 1 times 2. Gets it wrong. Punch him again. Updates. Okay, don't say that one again. Over and over and over and over and over again. Next time around, we say 1 times 1. He says 3. Punch him again, but he was a little closer, right? So maybe we hit him twice as hard this time to kind of really pop it in, right? So, Okay, so man, you don't know how many times you got cracked in class. Okay, now all of a sudden, next time around, we go 1 times 1. He goes 1. It's like, that's right. Don't hit him. And we say 1 times 2. Maybe he still gets that one wrong. We give him a little another. Okay. Now over time, he starts getting less and less wrong because we've kind of beat him into a pattern of the right answers. Okay, so the same thing worked here with our neural network. We fed it the 1 through 5s table. So 1 times 1, 1 times 2, 1 times 3, 2 times 1, 2 times 2, 2 times 3, blah, blah, blah. And every single time we fed it the inputs, had the desired output. If it got it right, we did nothing. If it got the answer wrong, if it guessed wrong, we punched it, right? We went through and we updated the network a little bit, kind of, did a little kind of chiropractic pops and stuff like that to hopefully make it a little closer next time. And there's some science, algorithmy stuff. The algorithm we use is something called backpropagation. Unimportant for this. Just we somehow updated the neural network to hopefully do better next time. Okay? And after thousands and thousands and thousands of iterations, it eventually got 100% of the 1 through 5's multiplication table correct. So we hit Jordan so many times that he was finally beat into knowing the 1 through 5's multiplication table. Okay? Now, well, how would we explain that? Well, first of all, would that work on a human?
Possibly.
Possibly. Okay, but this next part I don't think would. Huh? Okay, but so it's possible eventually, after hours and hours of beatings, maybe he would eventually memorize the 1 through 5's table, right? But this is where it was fascinating and magical for me. So we had this neural network, and we effectively, I almost think of it as like balancing it. I got this like weird thing, and it's just like in the perfect position now, this neural network, that it just guesses the right answer for the 1 through 5's table. Then we fed it the 6 through 10's table. Data it had never seen before. What do you think happened? It got like 98% of them right.
Really?
So what, if we treat that as a black box, what happened inside that neural network is we stumbled upon the pattern of multiplication. As human beings, we think of multiplication as a process, right? But how we represent that process in our brains is like magical to us, right? It's actually kind of one of like the interesting things of creation. Like somebody a whole lot smarter made that, right? So we don't perceive learning as stumbling upon patterns. But that's really what's happening, right? Is these connections inside our head, as far as we understand, ultimately are kind of webbing together until some kind of concept is understood. And then we apply that concept to other concepts, like you pointed out before, right? So sometimes we have an understanding and we understand something else in terms of a previous thing we understood. That's why we have like prerequisite courses and things like that. Okay? So when?
You were talking about data science and I used it.
Like 20 minutes ago? No, I didn't yell at you for saying pattern. I yelled at you. I said, tell me more. And then you started telling me a lot more, but then I cut you off and I said, well, pretend like you told me less, and that's funny. That's when I yelled at you.
But there's a part.
I'm trying to be artsy fartsy here. Come on.
Why'd you tape that post-it note over?
I didn't. That's from V.
She taped it over?
Yep.
So now you can never watch it.
I don't know. But she gets my drink a lot, although recently she hasn't been doing that, so she taped this on here.
V?
Yeah. So isn't this
It's
mean?
been on there for like 3 weeks at least.
Yeah. So what she says, she wrote on this, she said, extra Mountain Dew for extra fat people. Please do not touch. Huh?
What's the star for?
I don't know. I guess that means extra fat people? Like,
She had to elongate the word fact.
She had to make fat. Isn't that a mean thing to do? And she taped it on there to make sure I didn't forget.
It's not for you, it's for other people.
Lately, when she's been filling my drink too, she's been putting cereal and crap in there.
I know, that was really weird.
Oh, it was way worse yesterday. Yesterday was like,
Yesterday.
there was chia seeds in there.
That's just nasty.
I know. I started choking on it at the end of the night. That stuff starts retaining water and thickens up.
Yeah.
It's rough.
All right.
Where did you get cheese?
I know, something in the cafeteria.
So there's a question.
If it's not chia seed involved, it's not a question.
If,
Go ahead.
if our brain is kind of supposedly is also a neural network. It's a real neural network.
Yep.
And technically, we do multiplication. We can say if it's a perfect person, perhaps he can do 100% correct, even it's unknown multiplication.
Okay.
But definitely, if we do the machine learning, we can almost 100% sure say it won't get 100% right if it's unknown data.
Not necessarily. I mean, I've seen plenty of times where it has gotten it 100% right,
That is
but it is the nature of the data. Yeah, I mean, and also the
that is
amount of the data.
Really a lot. Say, if
Sure.
you give them 1 to 4, you don't let them get 6 to 10. It's really, say, 98 is really impressive. But if you say you put 1 to 1,000, then you give it 1,000 to 5, it will probably give a very accurate guess.
Oh, because it learned a broader set of the pattern.
Yeah.
Yeah, that's true. That's true.
So it's a. I do remember when I was in my formal studies, say in biology study, say introduce say this kind of thing is using neural network. We kind of say, okay, this probably is say this illness, but perhaps related to that kind of disease.
Sure.
Like the bacteria.
Yep.
But actually, then it can be say practical, but because it cannot be proved, because you don't know what the pattern is that.
Right.
You
Yeah.
can't get it out.
Yeah.
Then it's not technically it's useful, but it's not theoretically.
Yeah.
true.
So it's only useful so far as it's proven accurate in the future.
Yeah.
So you trust it as much as it has been accurate. And if something tends to have a high accuracy, even if you don't understand why, you tend to trust it over time, right?
Yeah.
You know, there's still people today that, farmers that tell when they plant their crops and stuff like that off the farmer's almanac, which will tell you what the weather is going to be at different days of the year in all sorts of years. Yeah, and they believe in it because I think there's some study that's shown it's actually either as accurate or slightly more accurate than modern meteorology. Which, does that mean that modern meteorology, does that mean that the Farmer's Almanac is magical? That it's somehow predicting the future weather? It was written years and years and years ago, and it gets it more right than meteorologists, or even as right as modern day meteorologists? Do you think that book is a magical book?
It has some truth inside, but
Why? Why is there truth in there? What does it really say? The fact that the Farmer's Almanac predicts weather as well as our professional weather predictors. What does that say about that Farmer's Almanac?
No, we should fire meteorologists.
Oh, well, that's one thing it could say. That's one way we could interpret that data. So, a couple ways, right? We could say the book is magical. How many like that one? Okay. See, this guy gets it. Okay. Everybody needs a magical book sometimes. Okay, we got book is magical. Okay, we got meteorologists are incompetent.
That's not what I said.
You're gonna fire them for what? What reason?
They are being replaced. It's kind
By the magical book?
Yeah.
All right, so we're replacing meteorologists, the incompetent meteorologists, with the magical book.
No, if you put them, they have the same skill level, but one is way cheaper than the other.
That's still incompetent.
So they're
Wait,
not that
wait.
bad.
All right, so either expensive competence or incompetent, one of the two. Okay, we'll use your word incompetent. All right. So one thing is that the meteorologists aren't worth the money, right? For whatever reason, would be nice. Okay, for whatever reason, they're not worth money, so we should fire them. Is there another interpretation of this?
Oh, the magic book?
Well, no, we're interpreting our data here. We have data. The data says that, if we take 365 days, we take, let's say the weather over the last 10 years. I don't remember what the exact numbers are, so just let me make some stuff up, but it's ballparky accurate based on some real study. Okay, so we're going to take the weather over the last 10 years. We're going to look at how well meteorologists predicted it, and we're going to look at how well this Farmer's Almanac predicted the weather, and we're going to call it a tie, just to keep things simple. So we can produce, and this Farmer's Almanac was written a long time ago. So we can interpret this a couple ways. Okay, we can say the book is a magical book. We can say, we can not just interpret the data, but we can make decisions based on this data in different ways. And we'll kind of get to that here in a few minutes. But so book's magical book, trust the magical book. That's one thing, right? Or at least trust it as much as we trust modern shamans that are doing this. Okay. Another thing is, you again want to trust the magical book. You don't want to call it magical, but you're thinking, look, the book is cheaper. It's already printed. Let's fire the meteorologists. Okay. What other conclusions can we make from this data?
Maybe the book has more huge volume of data since they were watching the weather for a longer time. So
Okay.
more data, and so their patterns, and they could predict better because they have.
Okay, so possibly the book isn't quite as magical as it seems. It actually is a tomb of knowledge based on a lot of observation. Which, hey, that's basically magical, right? Same thing, yeah. Okay, but possibly true. What else?
Accident.
Just dumb luck.
Yeah.
Who wrote it?
I don't remember. Yeah, because we could replace this argument with the whole Nostradamus, makes predictions about the future thing. But this is maybe something a little bit more sciencey. So, we probably can look it up, but it's unimportant in this discussion.
No, but I mean, who was predicting these things in the book?
It was. I don't think it was an individual. I think it was just a group of people, because it was called the Farmer's Almanac because it was this book that farmers, like people who did farming. They farm land.
Oh, that's for sure. It's just they had a lot of data. That's for
Yeah,
sure.
but whatever. The point is they have this book that would help them decide when to plant their crops and stuff like that. And they still, some farmers, I believe, still use this today. Okay, and there's some study that says that this is just as accurate as meteorologists are today. So we've come up with a whole bunch of conclusions we can draw. I haven't even heard the data that really probably feels most correct to me. The conclusion that's most correct.
Well, there's no patterns in weather.
Well, the book is magical seems exciting, but probably not true. Doesn't feel true, right? Okay. Do you think that these meteorologists are a waste of space, waste of money?
No.
Do you think they're incompetent? These guys go to quite a bit of schooling and stuff like that. So yeah, we could fire them and save a couple bucks because we got the magical, or save a couple bucks because we have the magical book, right? But maybe that's not that doesn't seem right, does it? And we don't even know this meteorologist, so it's not like we care about whether this guy eats tomorrow. All right, so what else could it be? Go ahead.
Side comment.
Question.
How are predictions made? The formula takes into consideration things like sunspot activity, tidal action of the moon, the position of the planets, and a variety of other factors. Only one person who knows the exact formula is the Farmer's Almanac weather prognosticator, who goes by the pseudonym of Caleb Weatherby.
Okay, so this is the Farmer's Almanac guy?
Yeah.
Okay, that's fine. So there's your backstory for Farmer's Almanac. It's crazy.
85% accurate.
Yeah. So.
But I do, I'm asking this because the people, I come from a small village in Brazil. The people there, they know. No, they know. I swear, they look there. They know if tomorrow's gonna be cold or if it's gonna be hot.
Oh,
And
those
it's
guys, they're out there
accurate.
smelling leaves and stuff.
I know.
You see the movie Twister?
Of knowledge.
Yes,
I never.
that's
Man.
the best
Bill Paxton, he goes outside, he's like sniffing the dirt. We got to get off this road.
Oh, yeah.
That's one of my favorites.
I swear. That's how I guess. That's probably
Flying cows.
old knowledge.
It's like, we got cows. I think we got cows again. I think that was the same cow. But okay, so I mean that's kind of the same example, right? He's out there sniffing the dirt and he's making ridiculously accurate decisions based off of it, right?
Did we say by chance already?
Well, yeah, I mean, Blade pointed out maybe they're just dumb luck. I translated. He didn't say that, but it was basic.
Accident.
Yeah, accident, dumb luck.
I think they just did so much knowledge from so many generations that they're able to they have enough wisdom to predict things.
But we have all this technology. We got satellites and all sorts of heat-seeking things and blah, blah, blah. I mean, we don't think that's better than sniffing dirt?
No. Oh, my personal, no.
We got the Brazilian storm whisperers here. They're hanging outside.
Well, as a technological person, I truly believe on science, but also
My
know
grandma
by
really
fact
knows.
that
We're back to grandma. She's the magician.
Yeah, as soon as grandma stops knitting, she's like, storm's rolling in. It's like, no, the weather guy said it's going to be clear. Like,
No.
20 minutes later, it's flooding.
That's how happened.
Grandma's inside making soup.
That's so true. It's
She's like, this is
crazy.
weirdly
No, hold on. This is really, I know this is actually starting to become like a comedy routine, but this is data science.
Yeah.
It really is. Can our meteorologists really be stupid?
no.
Our technology, our ability to, I mean, we can view the weather, all these patterns and stuff around the entire planet
Science
from
does that.
space and things like that today. Okay? You know, the storm whisperers in Brazil can't do that. Okay? They've been doing this off of, you know, like, I don't know, the shape of cucumbers or something like that. I mean, they've been making stuff up for thousands of years. Okay? Yet they're more accurate. Right? So, what's the deal? Do we just go back to the Farmer's Almanac?
Yeah.
Well,
Then
you
they
can.
won't.
No, because
I
we're
think in this case, science can learn from them some patterns and then apply.
Is it possible that meteorology is hard?
yeah.
That it's complex?
Yeah.
There's a lot of variables involved. I mean, even just think about these hurricanes, right? I mean, you have every single meteorology person in the world looking at one storm. And they can't decide when it's going to hit land, if it's going to hit land, where it's going to hit land, how powerful it's going to be, when and if it hits land. This is what it's like 50 miles off land. I mean, grandma's out there knitting, sees the hurricane. Doesn't know if it's going to hit or not, right? Why? There's so many variables that go into little tiny wind directions. Ends up pushing this giant storm just a couple of degrees one direction, which then makes it get picked up by something else, which maybe then steers it off of land. Or maybe it steers it onto land and now it's a horrible disaster, right? There are a lot of variables and it's very difficult to predict. And sometimes we have something called overfitting data. Okay, so I'll just put it on this slide. Let's put it on a new slide.
So does that mean actually if you only got 10% of the data, you can already giving say 70% of accurate prediction, but if you got 90% data, you still can only get maybe 75 or 72% accurate prediction?
Like it gets worse.
Yeah, or even worse.
Yeah. So I think that's pretty accurate. So it's this idea that, you know, with only a couple of data points, we can make a pretty good decision, right? But then as we collect more and more and more data, we start second guessing our original decision. We're adding too many variables into the equation. You know, some things might not be related and we just have even gut feelings about it. We become less accurate. So sometimes we take too many things into consideration that we end up drawing over concluding possibly the wrong thing because we've overcomplicated the problem. Does it feel fairly accurate to say that given all of our technology and all of these meteorologists and things like that are looking at these storms, does it seem maybe even probable that we have too much information that disagrees with each other, that it's hard to draw a real conclusion? That's why one of the things you see sometimes when you're watching like the hurricane coverage is, you know, model XYZ predicts this and model ABC predicts this, and model XYZ has been pretty accurate for Atlantic storms over the last 30 years, but model ABC is really, really, really good in Pacific storms or something. And they're completely disagreeing with them, right? One of the storms is, cutting Texas in half. The other one's going out to the east, missing Florida, right? They have totally different predictions. So with all of our technology and all of our ability to get a whole bunch of data, a whole bunch of data points, measure a whole bunch of things, are we almost putting ourselves at a disadvantage that we're working with too much knowledge, that it's hard to get that? What are the pieces of information that are most important is kind of the idea. There was an interesting study in a book I read recently. I don't remember which of the books it was, but it dealt with heart disease. And the idea was this: so this guy was a doctor, and he was working was dealing with heart attacks. So apparently in today's world we live. There's lots of malpractice lawsuits and things like that. So doctors tend to be overly cautious, right? If somebody comes in complaining about chest pains, not just that, but they tend to check them into the hospital, right? And a hospital bed costs a lot of money per night and all this stuff. So better safe than sorry. That's something we've heard a bunch of times, right? In general, human beings would say that makes some sense, right? Especially when you're dealing with something that serious, okay? But I don't remember the number, so I'm kind of pulling stuff out of the sky, but it's high. Something like 80% of the folks that get admitted to the hospital with a heart attack didn't actually have a heart attack. So that means only 20% of them did have a heart attack, right? Now, as reasonable human beings, we might say, look, that's fine, but at least we caught the 20. And the other people, maybe they had something else going on that was equally serious or whatever, but it wasn't a heart attack. So this thing only deals with the heart attack stuff. Now, there's all sorts of tests they can run in the hospital, right? But tests are expensive, right? And sometimes your insurance doesn't pay for the test and stuff like that. So one thing that doctors are trying to do is don't want to run a test unless you need the test. But sometimes they can run other tests that might be more or less conclusive, or they run 4 or 5 tests and those things don't agree with each other, all these other things. All these things pile up, right? So at the end of the day, the generalistic across the board thing was that something like 80% of people, let's just say in the United States, that are admitted to the hospital with chest pains, with possible heart attacks, don't actually have a heart attack. Only 20% that were admitted to the hospital actually had heart attacks. So one goal might be, well, since hospital beds are expensive and somebody else might need it more, if we can up that percentage of accuracy instead of having 80% false positives, maybe we can drop it to 30% false positives, something like that. That would free up those hospital beds for other people. That would reduce the insurance costs, which would then overarchingly, we hope, reduce the cost of medical insurance. It probably wouldn't. It would still just keep going up. But, whatever. You get the point, right? We'd like to put people in the hospital who are actually having a heart attack and need that treatment, and the people who don't scare them, don't do all this other stuff. So this doctor was working, I don't remember what it was, but it was like a fairly busy but didn't have a lot of money hospital. So they were kind of working with a shoestring budget where they even had to be careful about what tests they can run and stuff like that because they couldn't afford all the best equipment and things. So they created effectively an algorithm that said, here are, I don't remember how many points, let's say here are the 7 things, the 7 points, the 7 data points we're going to measure for detecting whether this person likely has a heart attack. And we're going to always make our decisions based on those. Now, a really experienced doctor could then go back and maybe override the decision if I just know something else is going on here, whatever. But generally speaking, they take these 7 data points and they applied it, and they ended up increasing their accuracy like tons. Like, I don't remember what the number was, but like a lot. I think it ended up being that something like 90% of the people they actually admitted actually were having heart attacks. So big, big, big improvement, right? And one of the things that they did is they took all those data to all the other tests that used to be run, and they gave it to all sorts of doctors and had them give their opinion on whether this person was having a heart attack or not. This was after they already knew whether the person was having a heart attack, and they got all sorts of different results, right? So even the highly trained, super experienced doctors could not with any sort of real accuracy interpret this data for whether or not somebody was having a heart attack. Make sense? So they created a simplified model that really did the measurement of whether or not something is probably a heart attack. So rather than looking for definitive information, because there is some ways, you use like a blood test, but it takes some time to run. So if you have some guy running into the emergency room grabbing his chest, you're probably not going to take a blood test and spend 2.5 hours waiting for the result, right? So it might be more than 2.5 hours. I don't know what it is, but there's some definite way of knowing from something in your blood. All right, but point here is that they dumbed it down to the point they said, is this person probably having a heart attack based on less data points? And it became a much better decision-making tool than having too much data. So more data isn't always better. That make sense? Okay, so we do have this idea of overfitting data. Anyways, so I talked about it in terms of like machine learning, where because it's a lot of times easier to happen in machine learning. Because one thing that we get a lot of little power hungry, right? Human beings, as we get the power tools in our hands, we want to maximize. You drive a sports car, you want to go 4,000 miles an hour in it, whatever it is. So if we have this computer that can crunch zillions and zillions and zillions of data points, we want to take advantage of that, right? But sometimes that's going to cause us to draw conclusions that aren't necessarily great conclusions because we had too much noise. Sometimes overfitting, we might call this noise in the data. Misdirection, right? Something's happening over there that draws our attention where the truth we're searching for is actually over here, but now we've gotten pulled a little bit off course because of maybe an anomaly or something that's completely unrelated. All right? Make some sense? All right. So data can be organized in different ways. And some of the ways data is organized may be beneficial for certain things, but having more data doesn't always help. Have any of you ever opened up one of those Excel documents where you have to scroll for a week and a half to the right? And then you got 4 million rows going down? And it's like unusable, right?
Yeah.
Okay, there's too much stuff in that thing for a human being to process. Now, maybe a computer program can make a little bit more sense out of that data. So, because a human being can get stressed out over something like that fairly quickly. Maybe there's only 20 or 30 columns, which doesn't seem like that many columns when you just hear the number, right? 20 or 30? But to a, yeah. So when a human being says there's 30 columns to the right, that's a lot of scrolling, and a lot of things you got to keep in track, and that's overwhelming to us, even though we don't think of 30 as being some ridiculous number, right? So I wouldn't immediately say, well, 30 different columns of information. is a problem. I wouldn't necessarily make that assumption because our computers are power tools. But with our computers, we also now have the ability to process a lot more information. And because we can, we might be influenced to try to do that. And that might make us overfit data or draw conclusions that aren't necessarily the best conclusions to be drawn. And this is kind of where organized data, and this is, I think data science ends up being kind of a nuanced thing, a pseudoscience even, where we can't say that a certain data set is good for data science. Because it's kind of a guess, isn't it? We don't know that we might overfit data or draw bad conclusions until we've already tried to process the data and tell a story from the data. So a data might not have enough information for us to draw good conclusions. It might have too much information to draw good conclusions. Maybe it has just the right amount of information to draw two conclusions, or maybe it's more probably it's somewhere in between. Maybe some of the columns of information are perfect for drawing some good conclusions, but when you start incorporating other columns into the equation, now it ends up dragging you away from it. So the same data set can be good for asking certain questions, but might be substantially problematic for asking other questions. Something like that. Okay? So we'll stop our, take a break here, but let's just stop with this one slide here. Data versus datum. Data is our collection of stuff. Datum is a specific row within that stuff. One data collection with all the pieces of information associated with it. Okay, that's how we're going to define it. Pandas actually defines it as inside of a data structure that we'll talk about. But a data is made up of a collection of datums. All right? Relatively unimportant, but I figure we might as well just spit that out there and then we'll start diving in. All right, so let's take 5 minutes. Yeah. And we'll come back at 8. Well, let's take 10 minutes. I can go check on my prints. So we'll come back at 8:25.